Hello everyone, welcome back. Now, let's explore a key building block in MuleSoft Agent Fabric, the Agent Network. An agent network has four core components: brokers, agents, MCP servers, and LLMs. If you understand them, you understand how MuleSoft coordinates enterprise AI agents. The first is the agent broker. It acts as the brain of the network, receiving user requests in natural language, interpreting intent, breaking tasks into steps, and routing them to the right agents. Unlike static workflows, the broker dynamically adapts its plan based on context and agent responses. It is defined in .agent file and published to Anypoint Exchange as a reusable asset. The second core component is the agent. Agents are autonomous specialists that use goals, context, and tools to complete specific tasks. Agent-to-agent communication uses the A2A protocol, which standardizes discovery, context sharing, task delegation, status updates, and result exchange across the lifecycle. There are two types of agents: locally defined agents and externally hosted agents. Locally defined agents are built and published in the agent network via Anypoint Exchange, while externally hosted agents run outside the platform but still collaborate through A2A. In our travel use case, we use four agents: flight booking, hotel recommendations, visa checks, and itinerary generation. Each agent is independently developed, deployed, and reused, allowing updates without affecting the network. The third core component is the MCP server. MCP servers provide standardized access to tools, APIs, and enterprise data. Since LLMs cannot directly execute system actions, MCP bridges this gap by exposing capabilities as reusable tools. MCP-compatible agents can discover and use these tools. Existing APIs can be exposed as MCP servers using MuleSoft MCP Bridge without changing core logic. For example, a legacy flight API can be surfaced for search and booking and immediately used by agents. This enables existing APIs to join the agent network through a standardized MCP interface. MCP servers connect agents to real enterprise data, grounding responses in trusted sources and reducing hallucinations. In our example, the airline API becomes a flight booking MCP server, the hotel system a hotel inventory MCP server, and travel advisories a visa check MCP server. Each provides a consistent way for agents to access tools and execute operations. The LLM is the reasoning engine of the agent network. As of today, the broker supports latest and greatest models from OpenAI, Azure OpenAI, Bedrock OpenAI, Google Gemini, and models via an Omni Gateway LLM Proxy. Model availability will continue to evolve as the platform expands. With the Omni Gateway LLM Proxy, only OpenAI and Gemini are supported. Other providers cannot be transcoded into OpenAI format. Gemini 2.5 Flash and Flashlight are optimized for speed, while Gemini 3 Pro with DeepThink is best for complex reasoning. Agent networks currently support text-only inputs and outputs. Images and binary data are not supported. All model configuration is defined in the LLM section of the agent script file. Together, the broker, agents, MCP servers, and LLM form a modular, reusable, enterprise-ready agent network. See you in next session where we will understand complete architecture.